In this in-depth video, we're going to take a look at DiGiCo's 32-bit converter options. Our flagship A to D converters have been available as an SD rack card option since 2017, with the D2A output card following a year later. And now, the local I/O of the new Quantum 338 console, launched this year at NAMM, features 32-bit technology on its local I/O. With a 24-bit audio transport between the SD racks and the SD and Quantum engines, we've been asked how this higher bit depth works with the consoles and what the advantages are. And first up, let's talk about the advantages of 32-bit conversion and why we do it. And the answer to this is really quite simple. It's all about noise, and more specifically, the lack of noise. When converting from analog to digital, with each additional bit of information, we increase the accuracy of the conversion process. So while 24-bit conversion gives us over 16 million possible quantization steps, the jump up to 32-bit pushes the number of steps up to 4.3 billion. This massive increase in digital values to represent the incoming analog signal means the quantization errors, that's the errors which result in noise when the signal falls between two digital values, is significantly reduced. So while a 24-bit conversion has a theoretical signal-to-noise ratio of about 144 dB, at 32 bits, this signal-to-noise ratio increases to 192 dB. Of course, this is theoretical noise, but because of the amazingly low converter noise, the real-life analog noise floor becomes much more about the component choices in our circuits, and this gave us the opportunity to control the shaping of the sound of our preamps. In fact, to perfect the design and to allow us to carry out subjective listening tests, we built a special preamp card that had 8 different designs on one card, all 32-bit, but with the different component values and surrounding circuitry. And this allowed us to compare the options and carry out ITU-controlled blind listening tests, and ultimately come up with a final design that not only measured and performed the best, but also which leading engineers and users thought sounded the best. We still haven't answered the question of how we use a 32-bit card with a 24-bit system. Again, the answer to this is pretty simple. We've talked about the noise and how we've designed a card with incredibly low noise floor, but any noise present as part of the preamp stage and 32-bit conversion is in the lower bits of the digital signal. So in order to use our 32-bit signal in a 24-bit system, we discard the bottom 8 bits. And this is, of course, where the noise is. We have our pristine 24-bit signal with a significantly lower noise floor than previously possible with 24-bit converters. The specifications of the final card make for impressive reading. A dynamic range of 119 dB, 0.002% distortion, a class-leading frequency response of plus or minus 0.1 dB from 20 Hz to 20 kHz, and a lightning-quick converter with latency of only 73 microseconds. So that's the input side, our ultimate Stadius ADC. But what about the outputs? Having launched the 32-bit preamp card, we set about making a 32-bit output card. Using the same technology and all the tricks and knowledge from designing the input card, we put together our ultimate Stadius 32-bit DAC. And the performance of our 32-bit DAC is equally amazing. A THD plus noise figure of 0.0008% from 20 Hz to 20 kHz, minus 99 dBu noise, which is 6 dB quieter than the 24-bit card, and a dynamic range of 121 dB, which is a 6 dB increase. Compatible with every DiGiCo console and built into the new Quantum 338 local I/O, the DiGiCo 32-bit converter technology makes a significant difference to the performance of your system. More transparency, quieter, faster, more accurate. Once again, the DiGiCo R&D team, led by John and Mike, have raised the bar. For more in-depth videos from DiGiCo, head over to our YouTube channel now or visit the website for more information.